Hey guys, we're going to have a quick thing going over the transformations. Alright, we started this yesterday, but if you don't have everything down that you see on this page right now, you might want to go ahead and put it on. Go ahead and take a snapshot of it or write it down or something like that, because we're going to be using it pretty extensively. Okay? So, this is what we're going to be doing first. We're going to do problem 1 together. It says, y equals the absolute value of x plus 4. Okay, so first thing, it's important to know, what does an absolute value look like in general? Well, an absolute value in general just looks like a v, okay? Absolute value. Alright, so usually this is what it looks like. Alright, but I have a transformation going on here. I have a transformation of plus 4. So what does that mean? Well, it means I move my graph to the left 4, so now my graph looks like this blue graph. The green graph is the parent function, y equals absolute value of x. The blue graph is this actual graph. So that's what I would expect for you to graph. Now, it asks for the domain and the range. If you're actually looking at the paper, it says, what are the domain and range for this problem? Okay, not a problem. Now, you see my graphs got moved. Let's see if I can't just move it back up here. Alright, so alright, you should remember that domain is simply the set of all x values. And the best way to do domain is to find the most left x value and then find the most right x value. Well, the most left x value is right here negative as an arrow. It's pointing to the left. So that would be negative infinity. And the most right x value is an arrow pointing to the right. So that would be positive infinity. So I could say parenthesis negative infinity, comma, infinity, parenthesis. Boom shakalaka. The range is lowest y value to highest y value. Well, my lowest y value on this blue graph is this 0 happening right here. And my highest y value is infinity, because it's an arrow pointing up forever. So I just say bracket 0 to infinity. Okay, I mean, that's it. That's all there is to that. Okay? So I urge you to try some of these other problems. Alright? Let's go to the next page here. Oops, I need to erase this. Let's try going to the next page. So on our next page, it talks about, instead of absolute value, it gives me quadratics. Okay. Well, it's still the same way. So first, let's refresh. What is the quadratic parent function? Well, it looks like a U. It's called a parabola. Okay, it's just going to look something like that, but without all the squiggly bad stuff. Okay, it just looks like a U. A flowy U, not a nasty U like mine. Alright, well, what does the negative sign in front of the x squared do to the graph overall? Well, if you remember from our transformation, so the negative sign tells me it's going to reflect across the x-axis. So it's going to look something like this. So then what is the domain and range if it reflects? Well, domain is still done the same way. Look for your leftmost x value. It's this guy. It's an arrow pointing to the left. Look for your rightmost x value. It's this guy, an arrow pointing to the right. So the domain is still negative infinity to positive infinity. What's your range? Well, now, this time, your lowest y value are both arrows pointing down. So that's going to be negative infinity. What's your highest y value? Well, it's right here. It's at the origin. That's 0. So you get to put a bracket. And that's how that's done. Okay, let's go on. Let's try some other stuff here. Alright, based on each function statement, describe the transformations from the parent function. Okay, so first, it likes you to state the parent function. Well, look here, we have absolute value bars. What is the parent function including absolute value bars? It's just y equals the absolute value of x. So then what is the transformation? Well, it's plus 2 inside the absolute value bar, so that just means left 2. What about this next one? Well, this one we have x squared, so that's the parent function. What's the transformation? Well, the plus 3 is outside, kind of like your function. It's outside the quadratic piece, so it's up 3. What about this one? Once again, we have absolute value bars, so the parent function is y equals absolute value of x. And then on this one, there's a negative 4 in front. Well, remember that this negative 4 is in the place where a usually is. And what is the absolute value of a if a is a negative 4? The absolute value would be just 4. So since 4 is bigger than 1, it's a vertical stretch by 4. But it was negative. So what does that negative tell me? It tells me it reflects across the x-axis. I'm just going to write the word reflects, but it does reflect across the x-axis. Okay, let's try going on to the last page here. Okay, the last page tells me write the equation for the described shifts and the parent function. Okay, so it tells me its absolute value, so I know I should have y equals absolute value. And then it tells me to go left 3. So how would I go left 3? Well, I'd say absolute value of x plus 3. Close the absolute value. It says up 7, so I write plus 7. Quadratic. Well, you know you're going to have something squared. And it says it reflects. A reflects means there's a negative sign right away. Parenthesis x. It says right 9, so minus 9. Close the parenthesis, and it's quadratic, so it needs a square. Alright guys, that's it. That's all that I'm just trying to give you a crash course in kind of maybe what you missed in class. Alright, but that's transformations, okay? Definitely make sure you have all these transformations down somewhere that you can use them. Okay, because if you don't, you're going to be in trouble, so you want to make sure you have them down. But let me know any other questions you guys have if you need help with anything at all. Okay? Thanks. I hope you have a wonderful day and a wonderful weekend.